Hello, this is Math with Beth. We're going to do graphing quadratic equations and learning about the transformations. There are simple transformations, but then they can get way more complicated. So I'm going to teach you how to do them in the nice simple way, but then I'm going to show you how to handle when these get more complicated and it's hard to just kind of do by shifting it on your own. Okay, so first, this is the parent graph of the quadratic equation, meaning it's the most basic quadratic equation, just having the x being squared. If you are not comfortable with the graph, you can always make a few points because you can always pick whatever x's you want, plug them in, and see what the y is that goes with them. So I am just going to always use these points as my parent graph because we are going to be using these points when we get to the more complicated ones to shift things around. So -2, if you plugged it in here, remember you're squaring a negative, so it becomes a +4. Same with -1 becomes positive. 0 squared is 0. 1 squared, so I'm just plugging these in. 1 squared is 1. 2, if I put it in, 2 squared is 4. If I graph those points, we would have a parabola that looks like this. Okay, so now we're going to talk about what happens when we shift things around. So go left, right, up, or down. Okay, so the first one is over here. First of all, since this is happening inside what is being squared, this is considered inside the function, where something like this, since it's outside of where we're squaring, is considered outside the function. The stuff inside deals with the horizontal axis. And you're going to see the pattern is we typically do the opposite of whatever it says. So this -2 is actually going to move us 2 to the right. So there's a way to do this with these points, but for now, since it's simple, I can just do it myself. Since I know what this graph normally looks like and all we're doing here is going 2 to the right, I can do that on my own because I know the pattern is that from that point, we go over 1, up 1, and then we go over 2, up 4 because of the squaring. If I wanted to do another point, it would be over 3, up 9, because again, if you square 3, you would get 9. Okay, so we're just going to do a couple of the simple ones, and then I'll show you the more complicated way to do it. So this one is again inside, so we think opposite, so that's actually going to move us left 1. But then since there's nothing else happening, the pattern stays the same, over 1, up 1, over 2, up 4, over 3, up 9, if you wanted another point. Okay, so those were the two examples of inside the function. -2 moved us to the right, the +1 moved us to the left. Outside the function always has to do with the vertical axis, so going up and down, and it is not the opposite of what you see. So when you see that +2, it is going to move you up. So up 2, and then from there, same pattern. Over 1, up 1, over 2, up 4. So what would this do? Again, because it's outside the function, it's not inside being squared, this would move us down 4. Right, and then the last simple transformation that we see is the negative. And if it's the negative outside the function, so that is considered outside, this would be inside. So make sure you see the difference. If it's being squared with the x, it's inside the function, but this one is outside. So remember, outside stuff was vertically, so it's going to flip this from the top to the bottom. So if you think about what this graph normally looks like, it's just going to be flipped. So it's still going to start here, but it's going to go over 1, down 1, and over 2, down 4. Okay, so those are the basic transformations, left, right, up, down, and the negative out front flipping. When they start getting more complicated, and this one isn't too bad, so I could do this one the same way. All it's going to do is end up doubling the y values, but I want to start showing you the other method because the sooner we learn it, the better. So since this is outside, it's going to affect the y. So I'm going to first remind myself of the parent graph and what those points were. So remember we had done this before. The parent graph, which is the most basic quadratic, is y equals x squared. So remember we had these points from the parent graph. So I'm now going to just keep using those points to change whatever's being changed here. So some things are going to affect the x values that were here, and some are going to affect the y. So anything outside is going to affect the y. And remember, the outside stuff, we don't make the opposite of what we see. So when I see that 2 out front being multiplied, that's exactly what I'm going to do to these numbers. So now, instead of having to go through and do all the work there, I can now basically ignore this and just focus on my parent graph numbers and change what needs to be changed here. So in this problem, all the x's should stay the same, but all of the y points that I had, I should multiply by 2. So if you do that, that will take care of whatever transformations have happened. So -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. So if you see, it's a much skinnier graph because that 2 is making it go up at a faster rate. So this 2 out front is called a vertical stretch. So a number being multiplied out front is called a vertical stretch because it stretches it up faster. Now let's see if we have the same number, but it's inside. So inside is the trickier one. Remember, inside is the horizontal stuff, so it's going to affect the x. And we always do the opposite. I don't know how I spelled that. The opposite of what we see. So remember when we saw a +1, we did -1. When we saw a -3, we did +3. Well, when there's something being multiplied, the opposite is going to mean flip. So again, let's go back to our parent graph. I'm just going to keep redoing this. So you can memorize this or you can just recreate it real fast, right? We just took these numbers and we plugged them in to see what we would get. So you can do that a few times until you end up memorizing it, but it's not too hard. So this is inside the function. So I need to be careful. I need to make sure that this stuff affects the x and that I do the opposite. So instead of multiplying my x by 2, I need to flip it and multiply by 1/2. So this time the y values should stay exactly the same as they were. But all of my x values that I had from the parent graph, I need to multiply by 1/2. So now let's see what that looks like. -1, 4, -1/2, 1, 0, 0, 1/2, 1, and 1, 4. So it ended up doing a similar thing, but because it's inside the function, it has a different name. So a number being multiplied in here is called a horizontal, either stretch or compression. So again, it's the opposite of what you would think. You would think a number like 2 would stretch it, but we actually call it a compression. So sometimes these names are important in your class. Sometimes teachers don't use them. So I'm just giving them to you in case your teachers use them. That's where they come from. Okay, so we're just going to do 2 tricky ones that involve a bunch of things, just to show you how complicated these can get, but how easy it is if you just do this method with the tables. So again, parent function. my parent function points. And now, carefully, what do I need to do to those? This is going to affect the y, and this is going to affect the y, and I don't need to change the way it looks. So for my y, I'm going to multiply by a -3 and add 4. For my x, I'm only going to do whatever's in here, but I need to do it the opposite. So when I see -1, I will be adding 1 to all of my x's. So I'm going to do the x's first because that'll be a lot easier. -2 plus 1, -1 plus 1, 0 plus 1, 1 plus 1, and 2 plus 1. So those are my new x values that I'm going to be plotting. But now for the y's, I need to be careful because I need to do all of this. I need to multiply by a -3 and also add 4. So 4 times -3 is -12 plus 4 is -8. If I plug in a 1, I would get -3 plus 4, so that's 1. If I plug in a 0, so make sure you're always plugging in the old y values. We're not plugging in the x values, right? We're taking these values that we got when we did the parent graph, and we're now changing them because of these transformation rules. So when I go to do this one, be careful, make sure you're going back to the old chart. Plugging in 0 would give me 4, plugging in 1 would give me 1, and plugging in 4 would give me -8. So let's see what this looks like. So -1, -8, 0, 1, 1, 4, 2, 1, and 3, -8. And so it should always be a symmetrical parabola that maybe just got shifted somewhere. So if yours looks totally different than that, then hopefully you'll be able to go back and see if you can find your mistake. All right, if you need it, here's one more, especially this has something tricky happening in here. When you see something like this in the parenthesis, what we would like is to separate the number that's being multiplied by the x and whatever's being added or subtracted. So the first thing I'm going to do is rewrite this by kind of separating that 2, so factoring it out, basically. If I pull the 2 out of this, it would be this. If you can see that. Still being squared, -1. Okay, so all I did was kind of rewrite this by pulling out that 2 so I could really see what's happening. I'm multiplying by a 2 in here, and I'm also adding a 2 inside here. So when I go deal with that, those are 2 shifts I need to do to the x, and I need to remember to do them the opposite way. So parent graph. There's my parent graph numbers, and now what do I need to do to them? To the x, I have a 2 being multiplied, so I need to remember to flip it. And then I have a 2 being added, so I need to subtract it. So that is me doing the opposite of both of those inside transformations. Outside of the function, I just have a -1. So remember, you do not do the opposite of that. So -2, if I multiply by a half, I would get -1 minus 2 is -2. If I plug in -1, I get -1/2 minus 2. So basically -2.5. If I plug in 0, I just get -2. If I plug in 1, I would get a 1/2 minus 2. So that would be a -1.5. And if I plug in a 2, 2 times a half is 1. 1 minus 2 is -1. This one should be a lot easier. 4 minus 1, 1 minus 1, 0 minus 1, 1 minus 1, and 4 minus 1. Okay, let's plot those. -3, 3, -2.5, 0, -2, -1, -1.5, 0, and -1, 3. So as complicated as it can get, as long as you just apply each of the transformations correctly to the x or the y, remembering to do the opposite for anything that's affecting the x, you should be able to graph any quadratic equation. I hope that helped, and I will see you next time.